Hi everyone. I had a question on one of I think it was a homework problem from 9C. This is the problem copied and pasted here. So I just figured I'd work through it in case it benefits multiple people, make a quick video out of it. So what I have here is, here's the question, and then also it's actually your final exam, but I'm not showing you the whole final exam. It's just one page of it that has some of the calculation, the formulas that you'll be provided with. There's more than just this, and you can see exactly what you'll get if you go to look at the modules closer to the final. But looking at this page and reading this problem, hopefully we can match up what we need and use one of the formulas and figure it out. So if you kind of read through this, you notice that it's about half-life. So you have a few half-life formulas down here. And this one is kind of an approximate half-life formula, and it doesn't say anything about approximating the answer in this one. So you're most likely going to use an exact half-life formula. Here's how you calculate the half-life, if that's what's being asked. And then here's how you do a calculation with the half-life. So if you're provided with the half-life, you can use this guy up here. So if you read through the problem, it does tell you what the half-life is. It says this substance, this radioactive substance, has a half-life of 20 years. So using the notation that this sheet is in, t with a little half in the subscript would be equal to 20 to do everything in years. So that takes care of this. And then if you go through and read, there's more information. Well, maybe I'll take it from the top. So we have this substance, a density of 6 milligrams per square centimeter. Okay, this is how much of it there currently is. And it was found in the ducts of a processing building that was used 55 years ago. Fine. So the half-life is 20 years, and what it wants to know is how much was there 55 years ago if there's currently 6. So this is kind of the current amount, or in the language of these formulas, this is the new value. And what we're being asked is, what was the density when it was deposited 55 years ago? In other words, find initial. So if you believe me that it's this formula right here, we have that new value, which we decided was 6 milligrams. I think everything's in milligrams. I hope everything's in milligrams. So we don't have to worry about that, milligrams per square centimeter, that is. So we got 6 equals the initial value, which we're trying to find the initial, maybe call it, I don't know, x, I guess is as good as anything. So x raised up to some exponent. The exponent you want is t divided by the half-life. T half-life is 20. I don't think I ever said that t is equal to 55. So what I have to do is take x, and I want to multiply that x. I know this looks like a multiplication sign, but it's not. It's x. I want to multiply that by 1/2, raised up to the 55 over 20. And so you have a few options in terms of how you do this. Probably what most people do is they take 1/2 and divide it by, raise it up to the 55 over 20 power, and then you get this number, and then take 6 and divide it by that number. You can do stuff more algebraically. You can figure this out more directly, but since I suspect the way that most people will do this is they will take the number 1/2, and they will raise that up to an exponent. The exponent that they raise that up to is the 55 divided by 20th power. And note all the parentheses. I want to get the whole 1/2 raised up to this power, and I don't want to just raise it up to the 55th power. I want to raise it up to this fraction, so I need all these parentheses. I hit enter, I get this weird number. So x times this weird number, this 0.14 thing, number is equal to 6. So if you divide both sides of the equation by this weird number, you get equals 6 divided by this 0.1486 thing. In other words, I can do 6 divided by, and then rather than type this whole decimal again, I can reference the answer. The way you do that is you hit this second key up here, and then this. And so 6 divided by the answer I just got, hit enter, I get this number. So I get that x is equal to 40.363. Do we have to round it to any accuracy? What was the density? So I don't know. Hopefully they tell you how much to round this to, round it to the nearest milligram or something. But this would be the approximate answer. And you can kind of do a quick reasonableness check. This thing is decaying, right? And it gets cut in half every 20 years. So I start out with 40. And after 20 years, I'm down to roughly 20. And after another 20 years, so here, how about a table? How much, maybe time, and how much of this stuff? And at time 0, I have approximately 40. At least that's what I figured out here. And so since the half-life is 20 years, it means after 20 years I should have half of 40, in other words 20. And after another 20 years, so I'm up to a total of 40 years, I should have half of 20, so now I'm down to 10. And if I went all the way up to 60 years, I'd only have 5 left. But I don't go all the way up to 60 years, right? I only go 55 years. So after 55 years, I'm not quite down to 5. I'm somewhere between 10 and 5, closer to 5. It looks like I'd be down to about 6, which is exactly the amount we have here. So this does seem reasonable. This seems to check out. You don't have to do any of those checks. All you have to do is the calculations, get an answer like this, type this into the system, maybe with some rounding going on, and call that good. I hope that's helpful for people.